The important topics which we are going to discuss here is definition of polynomial, relationship between zeros and coefficient of quadratic polynomial, then degree of polynomial and zero of polynomial, and then we will be doing some examples asked. Means I am talking about the examples asked in the paper. So let us start the topic with the definition. See, simply polynomials are algebraic expression that consist of variables and coefficients. Now let us see an example. So let me take p of x equal to 2x raised to 8 minus 3x raised to 4 minus 2x plus 4. Here x raised to 4, x raised to 8 are all variables. Then coefficient of x raised to 8 is 2. Coefficient of x raised to 4 is minus 3. Coefficient of x is minus 2. And 4 is constant. So now let us discuss degree of a polynomial. So degree of this polynomial, I can say, will be the highest power of the variable. So here, if I see carefully, here highest power is 8. So I can say degree of this polynomial is 8. And the important thing to be noted here is power or exponent, whatever we call, should be always a whole number. For example, if I am asked to check whether it is a polynomial or not, and I am given two examples like this. So this I can write it like this: x cube plus 3x square minus 2 into x raised to minus 1 minus 4. Now, here minus 1 is not a whole number. So, therefore, it is not a polynomial. And it is to be noted that variable power should always be a whole number. That is, it can be 0, 1, 2, 3 till infinite, any number. But it should be a positive number. You can't have a negative number there. Now, discussing the degree of polynomial, that is the highest power or highest exponent. So as we saw in the above example, it was p of x equal to 2x raised to 8 minus 3x raised to 4 minus 2x plus 4. So highest power is 8. So degree of polynomial, degree of p of x here I can say is 8. Then if I take a second example, like p of x equal to 0 x raised to 25 plus x raised to 23 plus x raised to 21. So here highest degree of polynomial will not be 25 but it will be 23, because 0 into any number will be 0. So I can't say it will have the degree 25 but highest degree will be 23. So therefore degree of polynomial will be 23. Now polynomials are classified into different forms. So let us discuss that. So polynomials, I can divide it into main three groups, that is linear polynomial. Now here the degree, highest degree will be always 1 and general form is ax plus b format. Then it comes quadratic polynomial, where highest degree will be 2 and p of x will be, general form will be ax square plus bx plus c. Here if I want to show an example, then we will be discussing the examples also. First let us see the third type. It is cubic polynomial, and this means degree will be 3 and general form is p of x equal to ax cube plus bx square plus cx plus d. Now let us see one example of each. So in the linear polynomial example, I can give as 2x minus 3. Here in quadratic I can give example as 2x square plus 5x minus 4, and in cubic I can say example as 4x raised to 3 plus 5x square plus 6x plus 4, or any such values I can put and I can say that it is an example. But related with 10, we are only asked quadratic equation in 24-25 syllabus. So now let us discuss zeros of polynomial. Zeros of polynomial. So it is the value of x by which the value of whole polynomial p of x becomes 0. So let us discuss example of that. Suppose if I take, let me take an example like p of x equal to 2x square minus 2. So what will be the value of x which I keep? So I will get answer 0. So p of x equal to 0 if I put x equal to 1. Now how? Let us check. P of 1 will be 2 into 1 square minus 2. So 1 square will be 1 and 2 into 1 will be 2 minus 2. So that I will get answer as 0. So therefore I can say x equal to 1 is 0 of the polynomial. Now if suppose I am given another example, let me take another example to find 0. Now p of x equal to 2x square minus 4. One is trial and error method which I used in the above one. I am trying to put 1 and find out whether I am getting the answer or not, and the other way is direct method. See, we know that if it is 0, p of x should be 0. So directly I am putting p of x equal to 0. So 2x square minus 4 will be equal to 0. So 2x square will be equal to 4. X square will be equal to 4 by 2. So 2 ones are 2 twos are. So I can say x square will be equal to 2. So taking square root on both sides, I can say x can be root 2 or x can be minus root 2. because square of both will be 2. So I will get two possible answers for the same. Now let us discuss relationship between zeros. Now next topic discussing is relationship between zeros and coefficient of quadratic equation. Because we have only quadratic equation in our topic, so we will be doing that in the 23 to 25 board. They have already informed that they will ask only the solution of quadratic equations. So now let me say, let alpha and beta are roots of polynomial p of x equal to ax square plus bx plus c. So sum of roots, that is alpha plus beta, will be always equal to minus coefficient of x upon coefficient of x square, that is minus b by a, and product of roots will be alpha beta, which will be equal to constant term upon coefficient of x square. So that is c by a. Now let us do one example with the same and understand it. So let me take one example. Find the zero of the polynomial p of x equal to x square plus 7x plus 10 and verify relation between the zeros and coefficient. So p of x given is x square plus 7x plus 10. So 10 such factors whose sum is 7. So I will get pi and 2. So first I am splitting the middle term to find x square plus 5x plus 2x plus 10. Now from the first two terms I am taking x common, so x plus 5. From the next two terms I am taking 2 common, so x plus 5. Now from both the terms or from both the answers I am taking x plus 5 common. So I will get x plus 2. So now I can say that either x plus 5 equal to 0, so x will be equal to minus 5, or x plus 2 equal to 0, so x will be minus 2. So these are nothing but the roots of the polynomial. So I can say here alpha is minus 5 and beta is minus 2. Now if I want to check the relations, so see, sum of the zeros was alpha plus beta, which is equal to minus 5 plus minus 2, so that is minus 7, which is equal to minus b by a, because b was 7 and a was 1. So I proved that. Now product of zeros equal to alpha beta, which is equal to minus 5 into minus 2, so that is 10, and that is equal to c by a. So 10's factor we did, so constant term was 10, so I got both the, I proved that the relationship between the zeros and coefficient. Now one pattern of sum which they ask in the paper is if zeros are given of any polynomial, or sum and product of the polynomials are given, and I need to find the quadratic equation. So quadratic equation will be k into x square minus sum, that is alpha plus beta x plus alpha beta. Here k is constant because I can get for more than one equations the same zeros. So sum of the zeros is alpha plus beta and product of the zeros is alpha beta. Now let us see with an example this thing. Find a quadratic equation if the sum and product of its zeros are minus 3 and 2 respectively. So I am given alpha plus beta equal to minus 3 and alpha beta equal to 2. So I can directly say p of x equal to k into x square minus alpha plus beta is minus 3. So minus of minus 3x plus alpha beta is 2. So this equation will become k into x square plus 3x plus 2. Now one solution for this sum and the zeros, sum and the product of the zeros is x square plus 3x plus 2. If I want more than one equation, I can multiply it with 2, 3, 4. So I will get that many equations. Now, let us see one more example which is asked in the board paper every now and then. Okay, this is not directly given to us that sum is this and product is this, but see, in a twisted way they ask us this question. If alpha and beta are the zeros of the polynomial p of x equal to x square minus 5x plus 4, then find the value of 1 upon alpha plus 1 upon beta minus 2 alpha beta. So see, here 2 alpha beta is given to me, but I don't know how to find for this. So there is a technique to do that. Okay, first if I take 1 upon alpha plus 1 upon beta minus 2 alpha beta and I do LCM of this two, so I will get alpha beta and beta plus alpha minus 2 alpha beta. Now if I know the sum and product, I can find this solution. So let us do it. So p of x equal to x square minus 5x plus 4. So 1 upon alpha plus 1 upon beta will be equal to beta plus alpha upon alpha beta. So beta plus alpha beta minus 2 alpha beta, as we have shown on the side in the box. So here alpha plus beta means minus b by a whole upon alpha beta means c by a minus 2c by a. Now if I solve it more precisely, I will get minus b by a into a by c. So a cancel, minus 2c by a. So now if I put the value, see minus b by a, so b is minus 5. So minus of minus 5 by a is 1, minus 2 into c is 4, a is 1. So this will be nothing but 5 and upon c was there here, so 5 by 4 minus 8. So now if I do LCM, so 5 4 will be LCM, so 5 minus 32. So I will get minus 27 by 4.